Alright, so this is section 6-4. We're going to be talking about rational exponents. But before we talk about rational exponents, we need to remember some of the properties of rational exponents. So, in exponents in general, this is true for anytime you have the same base, so a to the m times a to the n, it's like adding the exponents. When you're multiplying numbers like this, you're adding the exponents. So an example is if I have 8 to the 1/3 and 8 to the 2/3, that's really 8 to the 1/3 plus 2/3, and that's 8 to the first, and 8 to the first is really 1. When you're raising a power to a power, that's when you multiply the exponents. When you have two numbers inside the parentheses, raising it to a power, that power has to get distributed almost to both of those numbers, so then it becomes a to the m, b to the m. This one's really important, and we're going to be using it a lot in this section and also in the next section. If you have a to a negative exponent, that means that the number goes on the bottom of the fraction. So if I have, for example, 3 to the negative 2, that's the same as 1 over 3 squared, which is the same as 1 over 9. So 3 to the negative 2 is the same as 1 over 9. When you're dividing with exponents, we subtract the exponents. And then finally, just like as in multiplying here, if you have the fraction inside parentheses raised to an exponent, that exponent goes to both the top number and the bottom number. So these are really basic properties of exponents. You really need to know them. You should have learned them in Algebra 1. However, if you didn't and you need more practice, please come and see me, and I'll give you more practice with properties of exponents. Okay, so maybe you've never seen a fractional exponent before, so we're going to talk about what that means. We've seen the square root of 36, and the square root of 36 can be written as 36 to the 1/2. Those two mean the same thing. Just like if I'm taking the cube root of 64, that's really the same as 64 to the 1/3. Same thing over here. If I have the fourth root of 16, same as 16 to the 1/4. So we'll continue to talk about this a little bit more, but the bottom number, or the denominator of whatever the fractional exponent is always the index. And let's do some practice problems with that. So this is really important, that you make sure that you simplify your answer always. So we can write 216 to the 1/3 in radical form. Oops, sorry. We can write this in radical form. So it's an index of 3, so the cubed root of 216. But that can be simplified. So let's say 216 is going to break into what? 2 and 108, 2 and 54, 2 and 27, 3 and 9, 3, 3. So I have 1, 2, 3 3s, and my index is 3, so I'm going to cross those out right at one time. And I have 1, 2, 3 2s, so I'm going to cross those out right at one time. And then there's nothing left over, so nothing goes in the house. So my answer is going to be just 6. So that's how you simplify from a rational exponent. So we're going to do the same thing here. This time we want to simplify first. So since we have the same base, we're allowed to just add the exponents. So I have the same base of 7, I'm going to add 1/2 plus 1/2, and 1/2 plus 1/2. Hopefully you know that that's just 1. And 7 to the first is the same as 7. So your answer in B is just 7. Down here for letter C, this is a little bit different. So we have two different bases, 5 and 125. So I really can't add the exponents. Actually, we definitely can't add the exponents. So let's rewrite it in radical form and see what we can do. So we have the fourth root of 5 times the fourth root of 125. And we know that when you are multiplying radicals with the same index, you can multiply the radicand. So that's really the same as the fourth root of 625. And now if I break down 625, I'm going to get 5 and 125, 5 and 25, and then 25 breaks down into 5 and 5. So I have 1, 2, 3, 4 5s. My index is 4. So I cross them out right at one time. There's nothing else left over, so my answer must be 5. Try these. Pause the video and try these, and then I will put the answers up for you. And you can check your answers. Those were pretty easy. Okay, so what happens if it's not 1 over something? So we knew that a to the 1 over n was the same as making n the index, and we're still going to do the same thing. That denominator is always going to be the index. But what if there's a number on top, a number for the numerator? The numerator is going to stay attached to whatever your base is, while the denominator becomes the index. So that can be written like this or like this. And I'm actually going to erase my writing here so you can kind of write that down in your notes. Make sure you understand where those numbers go. And here's a really quick example. So if I have, for example, 2 to the 4/5, that's really the same as the denominator, remember, becomes the index. So it's going to be the 5th root of 2, and the numerator becomes the exponent, so 2 to the 4th. Those two are the same, and we're going to practice writing these. So let's try in letter A. There's 2 examples here, x to the 3/7 and y to the -3/2. I'm sorry, 3.5, 3.5. So 7/2. X to the 3/7 is going to become, well, the denominator is 7, so it's going to be the 7th root of x. The base stays the same. My numerator is 3, so the 7th root of x to the 3rd. The second one's going to be a little bit trickier. So this is really y to the -7/2, which is really the same as, remember your properties of exponents, 1 over y to the 7/2, which is really the same as 1 over, the denominator is a 2, so that means my index is going to be a 2. I'm taking the square root of y to the 7th, which is really the same as, if I'm simplifying, 1 over y to the 3rd times the square root of y. But this is still not quite done. Why is this still not done? I still have a radical in my denominator, so I have to get rid of it by multiplying by the square root of y over the square root of y. So now I have root y over y to the 3rd times y, because the square root of y times the square root of y is just y. So then that becomes the square root of y over y to the 4th. And that's your final answer. So in B, we're going to go backwards. So they gave you radical form, now they want you to write it in exponential form. So we know that when the index isn't written, it's really a 2. So this is going to become a to the 5 divided by 2, a to the 5/2. And then this one, our index is 5 this time, so we know it's going to be b to something over 5. The index is 5, and it's raised to the 3rd power, so 3/5. Pause the video and try these. Alright, so here are your answers for those problems. This one, it looks a little bit confusing. In letter A, the first one in letter A with the negative exponent, remember you have to put the negative exponent on the bottom first and then rationalize your denominator. This should actually be a multiplication sign, sorry. And you end up with this for an answer. The second part in A just becomes the 5th root of w. And then these are both of your answers for B. This is the first one, and then this is the second one. Okay, so now what happens when we combine radical expressions? We want to put them in simplest form first. Right now there's really nothing we can do in this form to simplify because they have different indexes and they have different radicands. So there's nothing we can do. But if we put it in exponential form, we'll be able to do something. So if I have x to the 3/4, right, because my index is 4 and I'm raising it to the third, over x to the 2/8, and I can simplify that because 2/8 is really 1/4, so I can have x to the 3/4 over x to the 1/4. And that's the same as x to the 3/4. Remember, this is from that very first page, properties of exponents, minus 1/4. And 3/4 take away 1/4 is how many fourths? 2. That's the same as x to the 2/4, which is really the same as x to the 1/2. And we know that x to the 1/2 is square root of x. So sometimes putting it in exponential form helps you in order to simplify a problem. Try these. Pause the video and try these. And here are your answers for those questions. The final answers are always down here at the bottom in the most simple form. This one you actually could have it written out. It's 7 to the 5th is really 16,807, so you could have had the 6th root of 16,807. That's all. Okay, so this is another property of exponents that we need to remember. Remember that when they're in parentheses and we're multiplying, you actually sort of have to distribute the exponent to everything in the problem. So this can really be written as -8 to the 2/3, and I probably want to put the -8 in parentheses, times x to the 2/3 times xy to the 1/2 to the 2/3. So then I'm going to take each thing at a time in order to simplify it. So the -8 is really going to become the 3rd root of -8 squared. The x to the 2/3 is going to become x squared, the 3rd root of x squared. And then my xy, remember when you're raising a power to a power, you multiply the exponents. And 1/2 times 2/3 is 1/3. So now I can rewrite this, the 3rd root of 64 times the 3rd root of x squared times the 3rd root of xy. And now I'm going to simplify this even more. The 3rd root of 64 is 4. And I can multiply that by the 3rd root of x. I'm combining these two together, so I have an x squared and an x, so that's going to be x to the 3rd and a y. Because I have the 3rd root of x to the 3rd, I could pull out an x, so my final answer is going to be 4x times the 3rd root of y. And that becomes your final answer for that problem. And we're going to do the same thing for letter B, except in letter B, we have a negative exponent. So you can do this one of two ways. I'm going to show you the easier way to do it, but if you can find another way and you get the same answer, you're welcome to do that as well. I think it's easiest to distribute the exponent first. So I'm going to have 16 to the -3/4 times y to the -8th raised to the -3/4. So now I really don't have to flip my fraction. I only have to flip it once because I'm going to end up with a positive number here. So let's do this one first. We don't have any variables. It's pretty easy to do first. We have a negative exponent, so it's going to have to go on the bottom. It's going to be the 4th root of 16 to the 3rd. and that's going to be multiplied by y. Remember, when I'm raising a power to a power, I'm actually multiplying. So this is a negative times a negative. It's going to be a positive exponent. 8 times 3 is 24, divided by 4 is 6. And now I can simplify. I'm going to have y to the 6th on top. And then if you do all the math out for the 4th root of 16 to the 3rd, you're going to end up with 8. So your final answer is y to the 6th divided by 8. We're almost done. Try these couple of problems. And here are your answers for these problems. And if you want a little bit of extra practice, you can try some of these. We're going to be doing a lot of practice in class on these. It's really, really, really important that you understand the properties of exponents. If you don't understand the basic properties of exponents, there's no way that you're going to be able to understand how to use those properties with fractional exponents. So please, again, if you need extra help with this, let me know right at the beginning of class, and I can do a short lesson on that as well.